Okay, so welcome back, guys, to a new chapter. In this chapter, we're going to work on a blueprint to create a sliding door this time. And as we move forward in our course, we're going to be adding more concepts to the blueprint process itself so we can continue to progress and enhance our knowledge, okay? So we'll create a simple door and a door that just slides in and out, okay? And then we could have a look at creating two doors that move in and out, and then maybe three. Each time we'll add another layer of complexity or another layer of skill to it. So we'll continue to progress. So what we'll do now is just focus on the theory of it all and not worry too much about the actual detailed mesh itself. So just put this sliding door frame over here. So what we'll do is focus on creating the blueprint functionality of the sliding door, okay, as if it's sliding like this. So it'll look as if it's almost like the door's embedded into a wall. So let's get started, shall we? And we'll use some of the same concepts that we used in previous classes. We'll just keep adding to our knowledge. So this way it will save time as well, okay? So what we can do is we'll use this door blueprint that I've created and we'll create a sliding door to it. So we'll duplicate that. We'll rename it to BP underscore sliding door. Okay, I think that's right. Cool. So we got that now. Let's open it up. Right, great. So we can see here we got our mesh. Now I'll change this because this door knob wouldn't work with it, the door handle. You wouldn't have that on a sliding door. So let's just change it back to a cube. And we'll just resize it just so it looks the appropriate size. Okay, almost there. That looks good. Okay, and remember the keyboard shortcuts. We can use those, or we can just use the option on the interface. But on the front view now, we can get the right height of the door. There we go. Just a little bit more. Perfect. Okay, so let's push play and then, sorry, Alt G. So I confused the keys there. So yeah, I'll add it in here. So we got you got a wooden material on that one. Let's find it in here. There aren't many materials in our scene, but we might have the wooden material. There we go. There it is. So we'll add that to the door. There we go. So now I can delete I've got this door. I can delete this one because I don't need that anymore. I just make sure it's in the right position in the hierarchy underneath the arrow. Okay. And then I'll just adjust it so it's in line with the arrow. So the arrow will work as the hinge. So now that should be correct. So we have our new door now. And it doesn't have the handle in the way. Perfect. Just what we need. And we've skipped a lot of steps, haven't we? Because a lot of it's already been done. But what we can do now is delete the comment, which is from our old blueprint. And let's have a look at what we need to do here. So let's think about this. We have our collision box here, don't we? And that's going to be doing the same thing. As the character walks to it, it's going to activate the door. But this time we want the door to slide, don't we? Slide to the left or to the right. And we'll see later on in the scene that it will slide to this side or that side, right or left. It doesn't really matter. When the character leaves, we want it to do the reverse, don't we? So we have our box collision. affected by our event begin overlap. And here we have our timeline. So the principles are the same. We just have to create a different type of curve or movement here. So here we have a curve going from 0 to 1 in 2 seconds, right? Sorry, 1 second it is, isn't it? Yeah, so the time is 1 second, or speed. We have a variation of values as well during the 1 second period, as we can see by the automatic curve. So we can reuse this because it's given us quite a lot of useful tools. Okay, so I can just change the name. That would be a good place to start. Let's rename that. F2 helps you to rename things as well, by the way. And what should we call it? Well, let's name it distance, since it's the distance that it's going to slide from and to. So that's going to rename this variable as well. So now that we've changed the variable to opening distance, now we need to look at this. So we don't have any rotation, so we don't need that anymore because we're just doing a slide, aren't we? So what we need to find a node that moves to the side instead of rotating. Now, I mentioned this before. There is a node called set relative location. So let's look for that. Set relative location, and there we go, arrow. That's what we want. So we've created our set relative location. Perfect. We're seeing the benefit, aren't we, now of having context sensitive turned on. So this new node we're seeing now is very similar to the one we had before, but we have we have the target in this case, which is our arrow, which is our door reference. By the way, let me just rename this because it's not a cube anymore, is it? So let's rename it to door. Nice. And here we have the position. So from this, we can put in the position that our mesh has. So we have the same node here for set world location, similar to the principles in a set relative location. So here we can have an absolute distance. So this would be a coordinate in our entire scene. So like a stationary coordinate, no matter where it is, it will always be that coordinate. And then the relative will add a coordinate to the coordinate it already has. So if it's in position 0, 0, 0 in the center of our scene, and if that is the case, and then we want to add maybe a 1 meter to the right on the x-axis, then I need to set this to 1 meter. And then it will go from 0 to 1, right? So if it's at position 2, 0, 0, 2 in x, 0 in y, 0 in z, if I add this, it will move a meter, okay? So it'll move to a new position from 2 to 3. It'll move 1 meter, 1 centimeter, whatever scale we're using here, and it will run that sequence. So hopefully that helps us to understand how it works, okay? Even if it's over a bigger distance, you can use the new location to animate that. So it's essentially here you can affect the position of the mesh, right? This is the difference between these two nodes. Now, in our case, we'll just use the relative one because we don't have to specify anything else. So let me just set the position of the door. So I can set this here. We'll do it the same way as we did for the door that rotated. So in the editor, we can adjust the value here, right? So let's go for 100 as the distance, and we'll go from 0 to 100. So now we have to know which axis the door is going to move on, whether it's X, Y, or Z. So how do we figure that out? Well, let's go back to our viewport and we'll select the door and we'll see its pivot, our mesh pivot. There's the X showing up. Okay, so the X is pointing here, which is the red one. There's Y and there's Z as well. So this door, you'll move from left to right depending on our scene. And we are navigating through the X axis, right? So we'll have to add this new coordinate to the X axis. It's the same principle as the other class. So I just open the split struct pin. Just going to split the coordinates into different variables. And I need to add this one to the X variable because that's what we want to move. And let's see if it works. Let's compile and save. And if what we're doing is making sense, sorry, let me just add the blueprint to our scene. We'll need that. And let's just go to top view. Let's all line it up first of all, before we go any further. Okay, let's get it in the right place. Nice. So we're just imagining there's a hole in the door frame that'll lead into the wall, okay? Just so it can slide that way. Okay, so here it is. We've got it in our scene. So now we can see that the opening distance is here, right? In the details panel. And now I can, no matter how big the door is, if we add another mesh, that's going to be the distance, okay? So it's going to move that distance in our scene. So let's push play and see what happens. So let's approach the mesh. And there we go. It's open. So it's slid. But this has gone the wrong way. We wanted it to slide the other way, but never mind. It slid further than 1 meter. It slid further than what we wanted it to, hasn't it? So let's set this about 80. So we set it to 80 since we didn't want it to slide too far in that direction. And negative distance will do it the other way, of course. There we go. See how it slid? Maybe minus 75. Is it going too fast, do you think? Let's see if we can make the slide a little slower. To do that, we need to go to the timeline. And we'll set it to be a length of 2 seconds. Okay, the time is 2, and then there we go. So we've increased the time. Compile. One more important detail is that we've already got into the habit, haven't we, of compiling and saving, which is really important. But it's important to do that because sometimes you might find you get errors in compiling. But if you don't do it and just push play, Unreal will compile and play, so you don't have to. But I always get into the habit of doing it just to be sure, so it can tell me if there are any errors beforehand. But there we go. It's sliding now, right? Nice. It's gone a bit further than we want it to be. You see there's a little gap there. But what matters is that the principle is working. The blueprint's working. Okay, sliding out the way. We can walk through. There we go. And as we move back, it slides back. Nice. So our blueprint's ready now. It's quite simple, wasn't it? Just because we reused the previous blueprint that we made and just changed the node, and just so it's using a different function there. But reusing blueprints are really useful. It saves time, and because of the way we set them up, they're just quick edits that we can make, as we did, outside of the blueprint in terms of the movement of the sliding door. So now, since we're talking about set relative location, I want to talk to you also about something else that's quite important. Let me just save this. We'll leave this to move a copy of it here. What I want to do is show you another timeline tool that Unreal gives us. Now, I didn't mention it in the last class when we were talking about the timeline. Well, I just showed you the float track, didn't I? Now, there is another kind of track which is called the vector track. And it's not a curve, but it's a vector type track. You might be wondering, well, what's the difference between the vector and the float? Well, the interface is similar, but we have free curves, don't we? So why do we have free curves? Well, because now, since this is a vector, we have free coordinates to think about, x, y, and z, right? So we have free curves to manage now. And that means that I can have simultaneous values in the timeline for the 3 different dimensions of our scene. I can move it not only one axis, but 3 axes at the same time. So how do we do that? Well, when you click on it, just here, it will show you to add a key to the x axis. And that's because here we have a line, but all lines are on 0. 0, 0, 0, 0, okay? So it's a straight line, x, y, and z. But the x-axis is over all of them. So when I right-click, it will tell me to add it to one key to the x-axis. How do I select the other one? Well, it understands what I've already selected, and we've got this tool here where I can just choose it almost like layers, so I can hide the x-axis, and then I can right click and I can add key to all curves. But that doesn't make sense, doesn't it? So why can't we see it? Why can't we see that the x-axis is hidden? Because you can still edit it. Let's see if we can work this out. So even if you don't see it, what's the reason for it still showing up? Now there's another tool, isn't there? That lock. So you can edit. So you can't edit it anymore once you lock it, right? So here, if you want to edit the y-axis, I have to hide z2, and then I'll add the key to y. And then to use the z-axis, I'll hide it and set up z. So that's if all the lines are overlapping. If they're not, then you can just use them as you would normally, okay? So now we can see them more clearly, okay? See them in their own unique colors. So here we have our 3 lines. So here's our starting point. Our 3 lines that represent the 3 coordinates that we can change in relation to time. 3 values at the same time. So let's create an animation for us to see this in practice, okay? So let's create something like this, some random coordinates. Don't worry about measurements. It's just so we can see what's going on. And I'll leave this one at 0. And I create another key here. And 0 here. And then on the y-axis, I'll do the same. I'll create a new key here. And bring it down here. And move it there. And I just set them all to automatic for their movement. Just so the way they move is smooth, okay, rather than being abrupt. And I'll create a Bezier curve. And this one is, make sure this one's the same. Almost like the automatic curve, right? So we have 3 different movements here, 3 lines, 3 curves, and it will generate 3 different values, one for Z, one for X, and one for Y. So now we got to this stage. Let's see this in motion. Let me just rename the vector actually before I go any further. There we go, call it vector, perfect. So we can see that now, let's just have a look. So I don't need this anymore. We can delete this part. I don't need this either. Great. So now we can see that there is also a new variable now added to our timeline. And that variable is the vector one we just created. Okay, cool. So a vector type, as we already said, provides 3 different bits of information. At the same time, though, is also applied, but we also have X, Y, and Z. So I can now go back here, and in our case, you can open up the pins if you want to, or you can regroup them. Let me find it here. Here it is, recombine structure pins. There we go. So it just puts it back to how it was before. And now we can see it's yellow, isn't it? So we can just connect now because it's set as vector. Now let's test it. But let me just see. I think we might have used a value that's too low. So it might be, you might not notice too much. Let's just amplify the effect a little bit. Because it's going from 0 to 1.59. So when you mouse over it, you can see the time. You see that? Just highlighting for us. So if you click it too, there's a time and value there at the top. But you can also highlight, you also see it when you just mouse over it. So we can either increase the scale, make it much higher, or multiply by 10 the distance. Multiply it by 10, for example. So if I multiply this by 10, whatever's 1.59 will now be 15. So let's multiply by 100. So we got 159, or 1.6 meters. Let's multiply by 100. How do we do this? We just follow the same principle before, drag and drop, and add the asterisk, which will be the sign for multiplying. So what happens here is that it's understood that it's a vector. So it's given us the multiplication in vector as well. So for me, what I need to do is get my variable. I can add it as a float type. Or actually, no, float isn't compatible, is it? So a float type has only, well, the float type won't work with that. So we just need to create another variable, a vector type. There we go. Compile it so it shows up here as well. And I'm going to multiply this. I multiply all the measurements by 100. And I can just come here, click and drag and drop, and it's multiplying X by 100, Y by 100, and Z by 100 too. And I'll place it here. Great. So let's see what will happen. I don't even know myself what will happen, but we'll see. Okay, because we set up all these random values. Let's see what happens when we approach it. Okay, right. So now we're in and it's shifted it over there. So as we got into the collision box, what we saw that happen is it just moved. But let me just increase the collision box so we get a better visual demo of what's going on. Let's approach it. Okay, so now we can see from a better distance what's going on here. So as I go into the overlap, what's happening? Let's think about this. So why did this movement happen? Well, we have here the X value, which starts at 0. The X only kicks in at around 49 seconds. And then at that point, it moves. For Z, it starts right at 0. So it goes up. And when it's here, it starts to slide to the right. It keeps going upwards to the right. And from 1.23 seconds, it starts moving on Y. So that's why we can see these jolts as it moves. They're not moving simultaneously, are they? So it goes up, and let's just make the collision. Let's just make this a bit more a bit longer, 10 seconds, okay. And then we'll drag everything over, just so we can see it going a bit slower. Don't worry about the scale, it's just so we can demonstrate it better. Let's just drag it like this. So let's use 10. No, we can't use 10. There is something I didn't mention before, that if you select two nodes, you can see it shows multiple values. So since these values are not the same, that's why it's labeled as multiple values. Okay, so you can't use them both as the same values if they're not, can you? Let's compile and press play. Okay, so it starts going up as I get there. And then, so it's moving on X and it's moving on Y at the same time as well. Do you see that? Right. So that's it. So with this timeline variable, this vector track we can use, and we can affect the movement of the three coordinates X, Y, and Z at the same time if you want to. We can even see that there is a distance curve here too. So should we go crazy now? Should we add a bit more detail to this? So what can we do? Well, we can add another node here, a relative rotation. We'll use the arrow 1, 2. Okay, so we got that all set up. Nice. And now I can add it here. So I can bring it right here. Okay, plug my target in. Let's leave it like this. And here I'm going to split the pins. And I can connect this to our distance in Z. And you can see that this was added afterwards, right? So why is that? Well, that's because we can't do it from here. You can't do it before, right? So we'll show you some tools that will allow you to create those intersections. But even if I created an intersection to follow two paths at the same time, the effect would be the same. It doesn't really change. Do you remember we talked about flow control in previous classes? So since I don't have anything that alters the time or our flow control here in this intersection, it will basically run both at the same time. Okay, so it's okay if it's before or if it's after. It doesn't really matter. In this case, it makes no difference really, because both will happen at the same time. When we press play, let's see what happens. Okay, so nothing happened really because I didn't raise it to, let me just, I raised this to 10, but let's just adjust that. Let's adjust the time to 2. Let me drag it a bit. Just so it takes a little bit longer, I'll change it to 10, to 8, set it to 1, okay, and put that in, set up our opening distance. I'll use this one, this variable of 100, it will open at 100 degrees. We're just playing around a little bit just to see what these tools do. And it's going to multiply this. And let's just connect it again. I mean, look at this mess. Not ideal, but we're just going to demonstrate something. If we want to, we can organize these lines a bit better. You know, if you want it a bit neater, for example, we can do it visually. This intersection's fine. It's only, yeah, for just demo, this is fine. But of course, reorganize it to whatever your taste is. I'll leave it like this just for now. Now we have our multiplication. We didn't have it before, so let's see what happens. Okay, can you see it's rotating? It's rotating and moving at the same time, right? Pretty cool, right? Oh, and by the way, we can rotate it in any axis. Any axis that we want. See, you can rotate it that way on the y-axis. Okay, right? Last, we'll see what happens on the x-axis. There we go. So that's how it rotates on the x-axis. So it's rotating 100 degrees, and that's why it's not parallel as well. I'll compile this just to make sure it's all set. Okay. And just to be sure, just to confirm, this mess we made was just for test purposes. Okay. There are some resources that we've talked about here that you might find useful in future projects. Here in the timeline, we had a look, haven't we, about the vector type. Now, they're not often used in ArcViz experiences, but I must admit, there are some here that I've never used before, but you might want to use them for games, perhaps, as you approach different doors or different actors in the scene. So you can use them to create different effects. Okay. Is also this color curve track as well, which is like the RGB color track. We can explore different colors and how they are changing or animating. So we got this RGB information instead of vector information here at the bottom. But the principles are practically the same. So in case you want to use a node to create or animate a variation of color, you can use it through here. So for example, I don't know, maybe you have a light and you want to adjust the color as you approach it. You want it to animate. Well, you can create it here under the color track. Almost like an LED light, for example. We can animate how the colors change as you approach or as you move away from the actor. And also you can affect the time it takes to change between colors. And also, if we enable autoplay, the timeline values will run on their own. Okay, so that's another feature in the interface. Even if there's no trigger. And loop also here is quite often used. So it's going to loop the animation and continue to go indefinitely. But basically that's it. They're the main features within the timeline. In ArcViz, these resources that we've talked about just recently are rarely used. I don't remember using them myself in the blueprint before, but who knows, you might use them too. So we've learnt some new features. We've had a little bit of a play, but we've been able to highlight some useful features, haven't we? We've kept our original blueprint, thankfully, so we can just put that in and use it as we would in ArcViz. So let's set it to go. We've got it going from play, and also we set up our reverse. So that should work. Now in this class, we've learned how to set the new relative location, and we learn also how to use different timeline resources. But in the next class, we'll learn how to incorporate more information to the sliding door. Okay, so I'll see you in the next class.